In this video, we will learn how to find all rational zeros of a polynomial function by factoring using Descartes' rule of signs. To do this, we will follow a 6-step process. Our first step will be to determine the number of variations in sign in the polynomial. To do this, we can look at the coefficients of a polynomial p of x and determine the number of times the sign changes. This will give us the number of positive real zeros. We will also check the variations in sign for p of negative x to get an estimate for the number of negative real zeros. This next step is to apply Descartes' rule of signs. This will give us a better idea of how many roots we can expect and what type of number they are. The third step will be to use the rational zero theorem to determine the possible rational zeros. Our fourth step will be to test the possible rational zeros we found in step 3. We will use synthetic division for this step. Once we've tested each of the zeros, our fifth step will be to confirm the zeros of the polynomial. Some of the zeros we found in step 4 may not be real zeros for the polynomial, so we will exclude those and only use the zeros that yield a zero remainder. Once we have found the zeros, our final step will be to write the original polynomial as a product of linear and/or irreducible quadratic factors. Let's try an example of this. Here we have the polynomial p of x equals x cubed minus 6x squared plus 11x minus 6. We'll use our 6-step method to write this polynomial as a product of irreducible factors. For step 1, we'll determine the number of variations in sign for p of x and p of negative x. So let's start by determining what p of negative x is. P of negative x equals negative x cubed minus 6x squared minus 11x minus 6. Now that we have p of negative x, we can determine the number of sign changes in each equation. We can see in p of x that we change from positive x cubed to negative 6x squared. Then we change from negative 6x squared to positive 11x. We then change from positive 11x to negative 6. So this means that we have 3 sign changes in p of x. Now we can look at p of negative x. We can see here that the signs of the coefficients are negative all the way through. So p of negative x has 0 sign changes. Now we can move on to step 2, which is to apply Descartes' rule of signs. Descartes' rule of signs states that the number of positive real zeros of a polynomial is either equal to the number of variations in sign of p of x, or it is less than that number by an even integer. So, we know that p of x either has 3 positive real zeros or 1 positive real zero. Descartes' rule of signs also states that the number of negative real zeros of a polynomial is either equal to the number of variations in sign of p of negative x, or it is less than that number by an even integer. Since there are no sign changes in p of negative x, there are 0 negative real zeros. Now we can move on to step 3, which is to use the rational zero theorem to determine the possible rational zeros. To do this, we need the factors for the constant term, which in this case is negative 6, and the factors for the coefficient of the term with the highest power of x, which in this case is x cubed. So, the factors of negative 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Since the coefficient of x cubed is just 1, we know the factors are 1 and negative 1. Now, we'll divide each of the factors of negative 6 by the factors of 1 to get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Since we have already found that there are no negative real zeros, we can discard the negative values, so we just have 1, 2, 3, and 6. Since we now have some values to test, let's move on to step 4. In this step, we will test the values we found in step 3 to determine which of them, if any, are real zeros of p of x. To do this, we'll use synthetic division. To set up the synthetic division, put the value you're testing to the left of the vertical bar, and then write the coefficients of p of x from left to right in the top row. We'll test the value 1 first. So we have 1 on the outside and 1, -6, 11, and -6 on the inside. First, bring down the 1 underneath the horizontal line. Then multiply 1 times 1 to get 1, and put the 1 under the -6. Then add -6 and 1 to get -5. Now multiply -5 by 1, write -5 under 11, and add them together to get 6. Repeat this process once more to get -6 plus 6, which equals 0. Since we do not have a remainder, we can conclude that 1 is a 0 of p of x. We can test the other values in the same way to determine that 2 and 3 are also zeros of p of x, and 6 is not a 0 of p of x. Now that we've tested the values, we know that there are 3 zeros of the polynomial p of x equals x cubed minus 6x squared plus 11x minus 6. So we can move on to step 5 and confirm the zeros. So we have 1, 2, and 3 as zeros of p of x. Since we know the zeros of the function, we can now proceed to step 6 and rewrite the polynomial as a product of irreducible factors. So, for our final step, we have p of x equals the quantity x minus 1 times the quantity x minus 2 times the quantity x minus 3.